Hi, good day, everyone. So today we are going to talk a specific topic concerning comparing the proportion of two independent populations using the Z test. Yeah. Okay. So let's discuss about the fundamental philosophy first. In this case, we are interested in, as the title states, comparing the proportions of two independent populations. Then we have two different populations, yeah, that are independent of each other. Says we have the population one is city of Jakarta, which is a metropolitan city, and population two is, let's say, Malang city, yeah, which is much smaller city, yeah. But of course, the population size of Jakarta is really large. Maybe I don't know, maybe 20 million inhabitants. I'm just saying a number, and then maybe in Malang it's more noble, yeah, more modest in terms of population size. Maybe only 1 million inhabitants, yeah. And then we want to, in this case, we want to the hypothesis is concerning the proportion of uh, of something. For example, the proportion of Android user, yeah, in Jakarta, yeah. So in Jakarta and in Malang, yeah. So for example, the proportion of Android user in Jakarta equals to 40%, and and in Malang is also 40%. Then the hypothesis statement could be, the proportion of Android user both in Jakarta and in Malang uh, is similar, yeah. Or we can also state it in directional form, like, the proportion of Android user is smaller in Jakarta compared to Malang, or the proportion of Android user in Jakarta is larger than the one in Malang. Yeah, if we see, suppose the population one is Jakarta and population two is Malang. Here I intentionally put some dots in it. Yeah, the dots is, the in our example is the one who uses Android phone. Yeah, so I put blue dot in there. Yeah, and also in Malang I put blue dot in there. Not everyone use Android user, but we are interested in comparing the proportion. There is a uniqueness in using the proportion parameter instead of the mean parameter. Why? For example, yeah, in Jakarta, let's say the populations is the population is 20 million inhabitants, and in Malang maybe 1 million inhabitants. I'm just saying a number, yeah. And then if for example, yeah, the populations in this 20 million inhabitants, the actual number of user who do use Android is 10 million. Yeah, 10 million means 10 million divided by 20 million means 50% of the user uses Android. And in Malang, for example, with inhabitant 1 million, the number of user who uses Android is 900,000. Yeah. Then, if we use the mean, of course, we see a very large discrepancies in terms of values. One is 10 million in Malang is 100 users. Yeah, very large discrepancies. Yeah. Then we can conclude, okay, the number of users who use Android in Jakarta is so much larger than the one in Malang. But if we talk about the proportion, yeah, even though in Malang the number of users only 900,000, yeah, and the total inhabitant equals to 1 million, then the proportion of people who uses Android is 90%. 90% of the people uses Android. But in Jakarta, even though the value is 10 million users, that the total number of inhabitants is 20 million, then it's only 50%. Then the inferences are different, right? That is the importance of how parameter, yes, how the specificity of the parameter, either its mean or its proportion, makes different, but leads to different inferences. Yeah, that's why comparing the proportions is also not less important than comparing the means. Yeah, because if we compare the means, then we tend to apa, ya to tend to omit the importance of the population size. Tend to omit, yeah, but not actually omit. Okay, and how in philosophically, how we do that? How do we prove whether the proportion or of the percentage of people who's using Android in Jakarta and the one who use Android in Malang is same? Of course, we pick several sample, yeah, or several respondents in Jakarta, and then, for example, from 100 sample, yeah, with sample size, how many of those 100 respondents who uses Android, then we can see the proportion of the sample in Jakarta. And also in Malang, we pick several respondents, and then, for example, also 100, and then we see how many percentage of the sample uses Android. Yeah, and by using the percentage of this sample both in Jakarta and the sample size in Malang, we infer whether the claimed hypothesis concerning populations in Malang and in Jakarta is close to the one that inferred from the samples. Yeah, if the values from the inferences from the samples is close to the one that to the stated hypothesis concerning the comparisons of two populations, then we accept the hypothesis. If not, then we reject. Yeah, similar like the previous hypothesis test philosophy. Okay. Now we go to the two most important tools, so might say, in doing the technical elaborations of the hypothesis testing. The first one is the cumulative standardized normal distribution table, or the Z table. Yeah, in solving the problems that you need the Z table. And the second one is of course the formula, which is as simple as this. Yeah, this is for the calculating the test statistics. We use the Z-stat. In this case, we use the Z-stat procedure, which contains Z-stats contain the proportions of variable of interest in sample 1 minus the proportions of variable of interest in sample 2 minus the hypothesized difference between the proportions in population 1 and 2, and then the pooled proportion and the sample size. Yeah, we will discuss about this later. Yeah, so here we can see the proportion of 1 is of course the number of variable interest in the sample divided by the sample size. Yeah, both in sample 1 and sample 2, and the pooled difference is simply summations of the number of respondent of interest in sample 1 and sample 2 divided by the total number of sample size plus total size of sample number 2. Yeah, we will discuss about it further through the problem set. I think it's better, yeah, than discussing the formula. Okay, like usual, yeah, in order to insert consistency throughout the different cases, we will use 6 steps hypothesis testing. The 6 steps approach, yeah, to do the hypothesis test procedure. First, state the null hypothesis, alternative hypothesis. The second one, choose the level, significance, and sample size. The third one, determine the appropriate test statistics and sample distribution. Number 4, determine the critical value that will divide the region of non-rejections and the region of rejections. The 5th one will be compute the value of the test statistics, and then the 6th one, of course, conclude with the statistical and managerial decisions. Okay, so let's discuss a problem set. Yeah, example. Suppose that you are a marketing manager of a fashion brand. Yeah, so you are the marketing manager, and yeah, there will be a new year coming. Yeah, and then you want to determine whether you will opt for the social media marketing campaign for 2 cities, Bandung and Surabaya. Yeah, so you are a marketing manager, and then you have specific budget, and then say maybe 100 million rupees, and then you have to decide whether you want to put all the marketing money, yeah, to promote your new products via social media or not for these two cities, yeah, in Bandung and Surabaya. Let's say that in Bandung, yeah, the social media campaign is quite success. Then if the proportions of the social media users in Surabaya is indeed pretty much similar with Bandung, you will decide that Surabaya will also conduct a social media marketing campaign. That's for example, yeah. And then you have to do that, yeah, to investigate whether the proportions of social media users in Surabaya is similar with the one in Bandung, even though the population size may very well different. Yeah, your team has conducting marketing survey, and yeah, and gathered this information, not conducted in Bandung. Yeah, you collected you interviewed 277 respondents, and 163 out of the 277 respondents used social media in Bandung. And in Surabaya, you managed to collect 262 respondents, and out of it, 154 are a social media user. Yeah, then the task is at the level of 0.05 significance. Is there evidence of significant difference in social media user proportion between these two cities? Yeah, so you want to determine whether the proportion of social media user in Bandung and Surabaya is similar or not. Yeah, because you want to decide for the marketing campaign. Okay, just go direct to the solving elaboration. First, stating the null hypothesis. Yeah, of course, yeah, the null hypothesis is whether the proportion of social media user in Bandung equal to social media user proportion in Surabaya, yeah? Or pi1, yeah, p1 equal p2. Yeah, that's the null hypothesis. Yeah, there is no difference in the social media user proportion between Bandung and Surabaya, or they are similar. Yeah? And then the alternative is the antithesis, of course. Yeah, state that there is a difference in the social media user proportion between Bandung and Surabaya. Okay, I think that's easy. The second one is selecting the significance level, and also some variables concerning the sample size. Yeah, choose the level of significance sample size. Yeah, at the problem set we can see, yeah, 0.05. Yeah, that is the alpha, or the level of significance, and the sample size. Yeah, at the problem set it is 163 out. So the sample size, all the sample is 277 for Bandung and 262 for Surabaya. Yeah. So okay, we state there. Yeah. 262. Yeah. And out of in Bandung, out of these 277 total respondents, 163, yeah, or X1 uses social media, and in Surabaya, out of 262, 154 persons use social media. So that are some variables that we will need for the calculations. Yeah. The third one, because we want to compare the proportion of two independent populations, we can use the z-stat for proportion. Yeah. Z-test statistics for proportion. Okay. Then we go to the fourth step, which is determining the critical points which divide the region of non-rejection and the region of rejection. Yeah, we have significance level of 0.05. Yeah, since the hypothesis is a similarity, yeah, so we divide the significance level in two directions because it's a two-tailed test. Then 0.05 divided by 2 equal to 0.025, which will be divided both in the left tailed and the right tailed, right? And then in order to determine the critical value, here we use the z-test, yeah, and then simply we use the cumulative standardized normal distribution table and then look for this value in the table. Yeah, here we find 0.025 null is located in z1 minus 1.9 plus 0.06, so 1 minus 1.96. Yeah, thus here we put 1 minus 1.96. Yeah, we plug it in. We plug in the value. Yeah, here, sorry. I just type 2 here. Yeah, so the z value is there for the negative side, and for the positive side, you just make an opposite. You make the positive value out of it. Yeah, so it's minus 196 and plus 196. So that is the critical value. Yeah, so now we have the critical value, and then the fifth step after we have the critical value, we calculate the test statistics, whether the test statistics is located within the region of non-rejections or either will be located in the region of rejection. Yeah. Okay. So 5. Yeah, collect sample data, organize result, and compute the value of test statistics. Yeah, the ultimate goal is to compute the value of test statistics. And as we know, we will use this formula, yeah, this is step for proportion, in which P1, yeah, the formula consists of the proportion of variable of interest in sample 1 and sample 2, number of size, number of sample size of sample 1, sample 2, and the pooled value. Yeah. So for proportion 1, we calculate how much people are using Android in the example is, I think, in Bandung. Yeah. The number of people using Android in Bandung divided by the total sample number of Bandung. Yeah. And then for P2, we calculate the total number of Android user in Surabaya divided by the sample size of Surabaya, and then the pooled proportions is simply summations of the number of Android user in Bandung and Surabaya divided by the sample size of Bandung and Surabaya. Yeah, and how we can get that value is actually very explicit in the problem set. Yeah, so with alpha 0.05, yeah, the number of sample size is 277. So let me see. Yeah, so actually N1, yeah, it's can already be supplied. Yeah, and also the sample size of in Jakarta or sample size of Surabaya is also there, so it should be no problem. N2 is already there also, and then the number of Android user of Bandung is also stated in the problem set. Yeah, X1 we can supply here and here also, and then X2 also. Yeah, the number of Android user in Surabaya. So actually it's not that difficult, yeah, because the x1 is already here, the value, the n is there, yeah, and then all the variables can be calculated, yeah. So let's start with the calculation of the pool proportion, yeah. So x1 equal 163, right? We plug it in here, and then x2 equals to 154, we plug it in here, n1 is equal to 177, we plug the value here, and then n2 is 262, we plug it in here, yeah, and then the result is 0.6483. Now we have already and then after that, yeah, we plug in another value, yeah, for the z step, simply by plug it in all the the component here with the values stated in the problem set, yeah. P1 equal x1 per n1, so x1 is 163 divided by 277, yeah, 163 divided by 277, and so on. P2 is also there, and then the pool proportion value is already calculated there. So just a matter of plug in the right value to the formula. Yeah, 1 divided n1 is also there. Yeah, so I think it's not a big deal. Yeah, and the hypothesized value. Yeah, this one. Yeah, we have the hypothesis that the proportions of Android user in Bandung is equal with the one in Surabaya, which means that the proportion in Bandung minus the proportion in Surabaya equal to 0. Yeah, with that, we compute the result will be 3.008. Yeah. Now we come to the very last step, which is very easy. State the statistical and managerial decisions. Yeah, so we have this region of rejections and non-rejections chart. We've computed that the critical value is minus 160 and minus 1.96 and plus 1.96, and then these are the critical value, and then we also computed the test statistics, which is 3.008. 3.008 is located, yeah, at the right side of the critical value, yeah. So 3.008 is lies at the right side of the critical value, yeah, of here. Yes, so it lies in the region of rejections, right? Thus, because the z stat, yeah, value equals to plus 3.00 is located within the region of non-rejection. I'm sorry. Oh, I make a mistake. Excuse me. Yeah, because the place is located within the region of rejection. Excuse me. So I make a correction directly. Yeah. Thus, the null hypothesis that states that the number of Android user proportions is equal. Yeah. The proportions of Android user in Bandung is equal with the one in Surabaya can be or must be rejected. Yeah, I think that's it. Yeah, it's very easy. Yeah, I think you all has already mastered the procedure, because it's pretty much the similar conduct. Yeah, the similar procedure either is one sample test, two sample tests, independent two sample tests, related populations, and then now we talk about comparing the proportion parameter. Yeah, I think it's fundamentally uses the same principle. Okay, then goodbye. Thank you.